Welcome back. In this experiment, we are going to see about dynamic routing. Before getting into dynamic routing, let's see what is a routing, right? So let's consider a case where there are many end devices and it is interconnected via a switch, and sending a packet from a PC to other PCs is pretty simple because this switch receives whatever message it has and it will send to the all the nodes and all the nodes whichever is the destined node will receive that packet. We'll see it in that in a moment. Let me send a packet from PC0 to PC2 and it doesn't work. Could anyone tell me why is the reason? I am unable to send a packet from this PC to this PC. Why is that? And it says no functional port. Yes, many would have guessed it correctly. I didn't assign any IP address for it. So let me make this particular network to be a class C address and preferably I take the default subnet mask and I always consider the last IP of usable IP of that network to the subnet I mean the default gateway, right? Likewise, I'm also keeping it for the other end devices also. Third device, I'm giving it as yes. Now I have successfully kept IP address for all these devices. Now let me check whether the packet could be sent from this PC to this PC. Okay, so let me see. It goes to the switch, and here you could see the switch is able to send those data automatically. So here the routing is taken care of by this local switch. Being it in the same network, the switch takes care of all the routing and other stuff. Now, what if I'm going to introduce you to another set of network? Say I have a example. If I take another set of network, right, and let this network be of say two network. I'm saying this has to be 192.168. I said this is one series network, right? So I'll denote it like this. And here let it be 192.168 and 2.0 network. Let it be like that. And so let's bring it to position. Yeah. And let me rename all the devices uh, by giving appropriate IP addresses. So here the gateway address is going to be 2.254 as it is being network 2 I said. So Yes, now I have successfully given IP address for all the network. I should say LAN 2. This is LAN 1, right? So let's send a message in between the LAN itself, right? So I'll take a packet, drag it and drop it between the networks and show it's successful. So let's try once again. So it's understandable because the packets are sent to the switch, and switch will know to which PC it has to be sent. It bases on the MAC address. So the switch will be knowing all the MAC addresses, and so it will be easily sending it out. Now, what if I want to send a packet, okay, from this network to this network? So what should I be using? I should be making it as a WAN connection through a router. So let me go to the network devices. Let me drop in a router, and connecting out is pretty easy. Let me take my say straight through cable, and let me connect it out, and similarly let me repeat it for the switch also, right? So I have successfully connected the two LANs to the router. But do you think the packet is going to be will be able to reach from here to here? That is LAN A to LAN B? No. Can it go between this LAN A to the router itself? No. And what message does it throw you? It's going to say no functional ports. That means what? The gateway of this particular router is not set. The interface has not been set. The interface will also be the default gateway for this network. So I have to turn on both of these two ports. So let me quickly go ahead, configure it. So first I'll be in user mode, right? So user configuration mode. So let me go to the privilege mode by giving the command called enable. Now I should go into configuration mode such that I can make changes to the router. Once I say I am in the configuration mode, I will go to this particular interface, that is FA0/0. How will I go for it? I have to give the command called interface, and I have to give fast Ethernet, and I should give the number corresponding number 0/0, right? And this network's gateway is supposed to be what? IP space address, and it is supposed to be 192.168. The last usable IP which I gave was 1.254, right? And the default subnet mask for the network is going to be 255.255.0. So let me give it, and once it's set, now I should turn on that particular port. So let me give the command called no shutdown, right? And let me come out of this configuration. If you could see this is turned to green in color. This indicates that the router is set for, or the port is activated, right? I have successfully set an IP and I have turned it on. Likewise, I have to go and configure this particular FA10. So let me quickly go ahead and make it up. Interface fast Ethernet 1/0, right? And I'm going to keep the IP address, say 192.168, and this particular IP has to be the gateway address of this particular network. So the gateway IP which I used is the last usable IP, that is 2.254, and the default mask is going to be 255.255.255.0, and here I give enter. Now I have to turn on that particular port, so I have to give the command called no shutdown, and it's on. And if you could see, now the router will be knowing that, so this is of the network 192.168.1.0 network, and this side, this particular through this port 192.168.2.0 network would be accessed. So the router takes care of the directly connected networks. So these networks are directly connected networks. So it will know where to route. Say for example, if I take a packet and I try to send to the router, it's saying successful. Likewise, let me take a packet from LAN A to LAN B. right? First time it will throw you this particular fail message. Now let's try again once, one more time. Let's see, let's debug what could be the error. So from here to this router, it's successful, right? Similarly, from this PC to this router, let's check it out. It's failed. That means we have done error. Maybe I would have done an error here. Let's check it out. Is it successful? No, it's failed. Now let's quickly see what error I have made, right? So I have given it as 2.1, 2.254, perfect. Now let's check the IP which I have given. I have given it as, if you could spot it, I have given the IP address as 92, then other than the 192. So let me go ahead, make the changes. So I have to go to the which interface, interface, FA 0, sorry, 1/0, and I have to give enter. And let me give the IP address once again, IP space address, and this time I have to be very sure that I have to give the correct address, 2.254, and the default address is going to be 255.255.0, right? So I give no shutdown to turn on the port. So the port is successfully now set, right? Now let's try sending a packet from this end to the router first and check it out whether it's working. From here to this, yeah, it still failed. Let's check it out once again. It's successful. Reverse way, let's check it out. Initially it won't, the first time it won't come because the updates would have not been sent. Other than that, it's going to perfectly run. Now let's try between the two LANs which are directly connected to the router, right? So I go over here, send a packet from here to here. Yes, it's perfectly running through. Now, there are only a few ports that could be connected to the router. What if there are n number of networks that has to be connected? So what happens in the real world is each networks, many networks might be connected with a router, and these routers could be interconnected with other routers, making up a WAN or a MAN. Okay, wide area network or metropolitan area network. So in those scenarios, how will the routing happen? So let me go ahead, remove this particular connection, and let me make it as a small WAN. Okay, so I'll just introduce you with another say a router, and everything is going to remain the same, right? I'm going to connect this particular switch with this interface and give FA00 with the corresponding IP address. What IP address? I have to use the corresponding IP address for this particular port, that is FA0. I no longer, I'm not connected here, I have to connect it over here. So how will I give it? You should go in for the privilege mode. So now it's in the user configuration mode. Let me go ahead, enable it out. Let me now go ahead with the next mode. The next mode is going to be your uh, configuration mode, config t. And what should I do? I have to go to this particular interface to set the IP address. So fa, yeah, fast ethernet 0/0, that's the port, I mean that is the part number which is being given. Now I'm in that part. Now let me get the IP address, IP space address. Now I have to give 192.168, and this should be 2.254 because this is 2 series network, right? So then I have to give no shutdown, I mean I have to give the default gateway, then following by that I have to give no shutdown to turn on that particular port. See, now what happened, this port is now connected. Now between these routers I have to make a connection, so this itself will become a network, as you are aware. So here preferably you can go ahead with your serial connections over here. Okay, you can use these kind of serial connections, and here you go, I'm going to connect these to my serial ports. Okay, there could be any number of routers interconnected with each other, right? So let's quickly see how this then also I have to set an IP address for it. So I'm going to use this particular IP for this particular network. Say for example, instead of 2, I'm going to use 3. Okay, so let this network be like this. So for this port, I'm going to use the starting address, usable starting address, that is 3.1, and this side I'm going to use 3 dot. The last IP address is going to be 3.254. So now let me quickly go ahead and configure it. Earlier I have set the IP address for say uh, 2.254. Now I have to rechange it. So what I have to do, once again I have to go to that particular interface, and I have to ensure that I'm selecting that particular port. This is serial 2.0, right? So for that I have to type in ESC and say 2 slash 0, right? Okay, now I'm inside that port. Now I have to set that particular IP address, IP space address 192.168. Then this particular network is going to be of the series 3.1, and the default subnet mask is going to be 255.255.0, and I'm saying no shutdown. I forgot to give clock rate. Being a serial connection, I have to give the clock rate, so I give the clock rate has to be 64,000, and I say it as no shutdown. Okay, so now this particular serial port is currently I try to turn it on, but it's currently it is stayed to down because I have to enable the other side also. Now let me go to the other side of the router, and let's configure this particular port also, serial port also. So I go over here, let me keep the IP address for this interface, serial uh, 2 slash 0, and let me go to that particular interface, and I've gone, and let me keep the IP address, IP space address, and the IP address for this is going to be the last usable IP address 192.168. Can you give me what is the last IP address for this? 3.254 exactly. So I can use this particular IP address, and it's going to be like this. Okay, now I give exit. Before exit I have to turn it on, so once again I have to get into this particular interface. So 2 dot, and I should say no shutdown. See, now the both the side it's turned on. Now let me quickly check out whether the ports are really working or not. Yes, so the connection is successfully set. Now let's try to send between the routers because it's directly connected. Yes, as it is directly connected, the packets could easily go from this network to this network. Yes, yes. Now let's try to send a packet from this network LAN A, right, to LAN B. It is showing failed. Could anyone tell me why this reason could be? Earlier cases, single router, this network was able to be connected. Now I am unable to do it. Could you tell me why it is? Earlier, these routers had the LANs as directly connected network. Every network was directly connected to it, so it was able to route it. Now, this router 0 will not know about this particular network is existing or not. All it knows is 192.168, one series of network and three series of network. It doesn't know that there is a network called 2.0 series of network. So what shall I do? I have to have a routing protocol enabled. So routing comes into picture right now, right? So there are two types of routing. One is going to be a static routing, another is going to be a dynamic routing. Static routing in the sense I have to configure this router and tell that these are the various networks that are available, and it has to go to this particular port, right? And I have to tell this router that there is yet another one network, one series of network available, and it has to go via this particular port. So if I'm going to tell all those things in a systematic way, that's going to be your static routing. Okay, it is good for a very small network as such as this, right? But what are the drawbacks of it is, once if I'm going to delete or add something, I have to update this particular router. If I'm going to add another network to it, I have to update all the routers over here, which becomes tiresome for a very huge number of routers and networks. So what is advised? We can go ahead with your dynamic routing. So in the previous experiment, you would have seen your routing with RIP, right? Routing information protocol. And you would have also seen routing information protocol for your version 2. In this experiment, we are going to see OSPF, right? So we are going to perform dynamic routing using OSPF protocol. So what is this OSPF protocol is? It stands for Open Shortest Path First Protocol. Okay, and you should be knowing what is routing information protocol, and it works on the principle of Dijkstra's algorithm. Okay, OSPF works with Dijkstra's algorithm, and RIP works with Bellman-Ford algorithm. This is the core base algorithm for the OSPF, whereas in RIP it's going to be Bellman-Ford algorithm. So it works in a certain principle, right? So your routing protocol should work with the core principle. So how does it work? It works with this Bellman Ford, and here it's going to be Digitras. So the base, the type of algorithm followed in RIP is going to be a distance vector. It should be based on distance, whereas in OSPF we use something called as link state protocol. Okay, so you should be knowing in open shortest path. So the type of algorithm used is Dijkstra's algorithm, which follows link state protocol. Okay, based on the link state, it's going to the algorithm or the routing is going to happen. Okay, RIP is limited to 15 hops. Okay, there is no limitation of any hop limits in OSPF. This is a major advantages. So it could be used for a very huge networks. Okay, it could be able to find a large set of networks routing using your OSPF. So metric is calculated via your hop count. So routing is measured, okay, is based on a metric called as hop count. Here it's going to be your bandwidth. OSPF is going to work with your bandwidth. So UDP is used for your RIP. Okay, the type of network layer protocol used is your UDP. OSPF works with Internet Protocol. Okay, IP protocol. Basically, it's a TCP protocol. Okay, so these are the major properties of your open shortest path first algorithm, right? So we'll quickly jump into your comments, right? To configure your OSPF settings, or to enable your uh, OSPF in a router, you could use you have to enter into configure mode first, and you have to use a command called router OSPF and process ID. Process ID you can give it as one, any numbers. This is just an arbitrary number. Okay, and here in the second line you have to you give the uh, directly connected network address. Okay, so earlier if you would have remember, we had three networks, right? So that corresponding network address I have to give, and the wildcard mask. Sir, what is this wildcard mask? Wildcard mask is the straight opposite of your subnet uh, value, right? Subnet mask. So if it's for class C, say for example, the default subnet mask is going to be 255.255.255.0, right? For the same thing, wildcard mask is going to be 0.0.0.255, the inverse of your uh, subnet mask. And you are supposed to also give something called as area and the corresponding area code. Okay, areas are like 6 in numbers. You can have, this is used to denote differentiate various networks, say for example, which is going to be the backbone networks and other stuff. Okay, there are like where 6 areas, you can go have a look over it. Now preferably we'll use area 1 for in our exercises, right? So what are the other commands related with your OSPF are going to be like this. This is used to show your IP routing table, right? So IP protocols we are going to check, and we are going to see all who's my neighbor, what and all interfaces are enabled with it. All these commands we are going to check it one by one. So now we'll just quickly jump into your exercise. Let me go to my packet tracer, and let me enable routing here, and let's check out whether all the IPs are set. Any unneeded IPs are set. Let's check it out. If you could see, I have an extra IP given for fast Ethernet 1/0. It is no longer needed, so let me go over there, remove that particular IP address. So let me exit it out. So I should go into I that particular interface fast Ethernet. uh, I think it's 1/0, right? 1/0. Yeah, so I should say no IP address. Yeah, now it's set. Now let's confirm it out. Yes, it's perfectly fine. Only the required directly connected networks are given. Likewise, only the directed connected IP addresses alone are given. Okay, the same thing has to be given for your configuration also. So let me go ahead. Okay, so I am in the configuration mode, so I should give the first command. So let's see what is the first command. First command is going to be router OSPF and the process ID. So let me give the command. So the command is going to be router, and I should say OSPF, and I said the process ID, let it be say 0 over here. This is an arbitrary ID. This is not going to be used propagating anywhere. It is just for the reference of that particular network. So I am giving to give it as OSPF 0. Let's check out. I'm sorry, I have to use greater than 1. Okay, now I have given it. Now I am in the particular OSPF configuration mode, right? So I am in the OSPF configuration mode, that is denoted by config router. Now I have to tell the corresponding IP addresses of the router 0. Now let me go to the network, right? And let's see what are the networks that are directly connected. The directly connected networks for this router is going to be the series of 192.168.1.0, and here it's going to be 192.168.3.0. So two networks are directly connected. So let me quickly type it in. So I have to give the command called, right, network, right? So network and the corresponding IP address, network address 192.168.1.0, and I have to give the wildcard mask. Wildcard mask, I told you, the inverse of your subnet mask, and here it's going to be like this, because the default subnet mask of classful address is 255.255.255.0. Here I'm taking the inverse. Then after that I have to give the area code, right? So this is what of the formula standard says, right? So your thing says I have to give area and the corresponding area code. So let me have it as say area 1. Okay, and let me give enter. Likewise, I should say talk about the directly connected network. This network is going to be 3. Then I should say enter. Okay, then I exit this mode. So I have just right now configured OSPF for this router. Now let me go over here, right, and perform the same operations, right? So router 1 I should go give enable, right? Now I should go to the config mode. After that, let me set the IP. I should go for my router configuration. So router OSPF, and let me give the ID as 1, process ID as 1. Now let me go and talk about the uh, second thing, router network, and I should give the corresponding directly connected networks. Directly connected networks are 2.0 networks and 3.0 network, right? So these are the two directly connected networks. So let me type it in: 192.168.2.0, right? And I have to give the wildcard mask 0.0.255. and the area code I have used it as 1, so let me use the same thing and I give it. Likewise, I have to talk about the corresponding IP or the other network, which is 3.0's network. So I'm going to do this, and I have successfully configured it. Now let me give exit. Okay, now let's check out whether the and when I give immediately exit, you could see really what is happening. See, the routing OSPF routing packets has been dispatched and the route is automatically found out. Okay, so how do you check it out? Is you can go to the normal privilege mode. We'll try out the each comments whether this is really working or not. The first one is show IP route, right? So let's go and give that particular command, show IP route. Okay, so we'll give the command and see show IP route. See, you could see CC are directly connected networks, and here the O represents that, right? This is the other network which is found out by OSPF, and it says it has to pass via 3.1 to reach to this particular network. See, now we will know that whether we have successfully configured or not, right? Likewise, the other now we have seen this route command. Now let's see the next command, show IP protocol. See, now it's going to tell me what type of protocol I have used. Okay, whether is it going to be RIP, whether it's going to be OSPF, what type of protocol has been used in the router. So here it's going to be OSPF. Now we should be asking me a question, sir. Can I have a different routing protocols for different routers? Not preferably, right? We should ensure that only a particular set of routing algorithms are there in all the routers such that it can communicate between itself, right? So it does. Now you can see through this command, show IP protocol will tell you that the particular IP protocol used is your OSPF. Now we'll check out your next command. Next command is going to be show IP OSPF. Show IP OSPF. Here it's going to talk about your all your IP addresses. I mean your ports, all these things, linkages, how many ranges are there, right? All the detailed things about your OSPF, right? And next command, let's check it out. OSPF brief. I'm sorry. I think it should be interface brief, right? Which are the interfaces that are being used? Okay, interface brief. Let's check it out. It's so let me check out. So it's going to be IP show IP OSPF interface brief. And what is happening is, let's check out with this thing, show IP OSPF neighbor. See, it talks about who's my immediate neighbor, what all the devices that are connected with, right? And let's check out show IP OSPF. I'm trying to get here you go. The interfaces is coming. All the things about the interfaces on the router is going to be given. When I say brief, I think BRIEF. It should work. It's not working. Anyhow, when you give this particular command called interface, right? Show OSPF interface. It will talk about all the interfaces that are available out here and which uses the particular OSPF. And it will talk about your cost, which will be the shortest path. All these things, data could be used via and found out via this particular OSPF interfaces. Right now, let's really check out whether our packet is now able to send between the LAN A and LAN B, which is our primary objective. So let's take a big packet and let's go and send it a packet. First time it will be always it won't be coming out. Let's try out once again. Yes. Now you'll be able to send a packet from this network to the other network successfully via your OSPF configurations. Pretty simple, am I right? You have just given how many comments? Just two lines of comments, right? One is you're going to tell that it's going to be the router OSPF. That's the routing protocol you're going to use, and you're going to tell about all the directly connected networks. Once you do this, the routers will take care and it will interconnect itself and it will find out which network it is. Now, for your experiment, what you can do is first you can try out with this particular thing and you can take a separate screenshot of it. And additional exercise, what you can do is you could have say another router. Okay, you add another router to it, and what you can do is you can have a connection like this. Okay, you can have say you could have a connection like this and also like this. Okay, and you can have another LAN over here, and so let it be LAN A, LAN B, and LAN C, right? And it should be connecting via your three routers. Now the condition now here is I have used class full IP address, right? So RIP version 1 also supports class full addresses, right? Here for this experiment, while you are doing for the second one, right? So what you can do is you can do it via your classless addressing. Okay, that means what you're going to have a variable subnet mask, okay, for each network. And now try out whether this is really working or not. Okay, uh, I hope you understood. So now the directly connected networks are going to be like this particular LAN, which might say 192.168.4.0, and here it's going to be like 3.0 and 4.0. These these three networks are now directly connected, so it has to be told. Likewise, this router has two directly network connected, and here this router has this network and this particular network. So you have to promptly give the corresponding network address, and you could be configuring this particular network. The outcome of this particular experiment is going to be like you should be able to traverse packet from any network to any part of the network. Okay, from any LAN part to any other LAN part which is of a different entirely of another network. So this will be objective through your OSPF routing protocol, right? I hope you have understood. For any clarifications, please contact us. Thank you for watching. Have a nice day.